Today we are going to run through a bit of reverse engineering inside of NX. We want to take a look at the air path of the cylinder head. We scanned the areas we're going to be working on, and really that's when the real work starts. I say that because with modern scanning systems like our Zeiss Comet have become extremely easy to use, and there's a lot of data coming out. A lot of good, clean data at that. Typically, that data is going to be a triangulated mesh, typically in an STL format. With that, STLs can be an extremely heavy file format. So one of the first things I usually go about doing, other than switching the colors, is trying to manage some of that file size. We have a handful of tools inside of NX to really do just that. One being the snip tool, allowing us to section off and or delete portions of our data. We can also run things like Decimate. Decimate is going to intelligently look at our model and remove some of the triangles that actually make up our model. Also inside of here, we have some cleanup tools, fixing erroneous triangles, flipped, disconnected data. But typically in my process, I don't really need any of them. Speaking along the lines of fixing issues, we're pretty much always going to have to fix the origin. And working with scan data can be quite different than working with CAD. So of course you can just pull the model around, but you're probably going to want to set it a bit more intelligently, a bit more precisely than that. So what I'll typically do, using a paintbrush tool, simply fit some surfaces to our mesh. Also, we can use one of these segmenting tools that'll allow NX to interrogate the model and define regions shown in these colors that'll allow for even easier selections. Again, fitting data directly to the mesh. Now to make the information a bit more palatable for NX, there are plenty of ways to go about this. For this particular part, I find it easiest just to use a sketch. But that process is going to vary from part to part, depending on the information you have. And now we're really working with standard information. So it's a bit just normal process. Using normal NX tools to do normal NX things. Here we have our coordinate system, moving this part from CSIS to CSIS. So in this particular instance, we've just aligned our CAD data to the origin. Now we can start to work with the actual data. So as we showed before, we can fit surfaces directly to our mesh, but we can fit more than just the primitive shapes we showed before, simply by defining a curved network. NX can fit a surface, a free-form surface, directly to the mesh. But I at least try to be a bit more traditional, I suppose, and work directly with sketches. That sketch can start from a spline, a cross-section of sorts, going directly through our part. Or what I find even easier is just using a view section inside of a sketch and tracing the rendered edge. And again, we're sort of back to business as usual, creating sketches, then extruding, revolving, using edge blends, coming up with the geometry required for our part. And at any given time, it's always good to validate, checking our CAD geometry to our 3D scanned object. Here inside of the deviation gauge, we can do just that. We'll have a color map, much like we've seen before with analysis, showing gaps, showing how well we've done. This allows for a very quick judgment on how well you're doing or how well you've done. Here we can understand areas where maybe we need to take another look, spend a little bit more time, or the effects of corrections for something like symmetry may have on our part and the deviation that it creates. Really doing all of this is sort of the process I typically go through. Separating our mesh data into logical pieces allows me to easily wrap my head around the process required to create all of the features necessary to create our part. And this is a standard native NX file. Can be exported in any standard CAD format and can be used as you normally would for any downstream application. This part is going in for flow analysis. This process will allow for a very accurate, quick and accurate representation of our physical part to be used in some sort of application for flow.